It is a pleasure to be with you in class, scholars. In this class, I will be teaching you the topic Mensuration of plane shapes, and our focus in this class is on circles. A circle is a round plane figure whose boundary or circumference consists of points equidistant from a fixed point, which is the center of the circle. A circle have many parts. You have the radius, the sector of a circle, you have the diameter, arc, chord, segment, and the circumference of a circle. In this class, I will be teaching you the different parts of the circle and how to solve problems involving them. The first part we'll be looking at is the diameter of the circle. The diameter of a circle is a straight line segment which passes through the center of the circle and has two endpoints on the circumference or the perimeter of the circle. The next one we'll be looking at is the radius of a circle. The radius of a circle is the distance from the center of the circle to any part of the circumference of the circle. The third part we'll be looking at is the chord. A chord is a straight line joining any 2 points on the circumference of a circle. A diagram of a chord is shown on the screen. So how do you find the length of a chord? Let's take an example. The radius of a circle is 17 centimeters. And the circle is 8 cm from the midpoint of the chord. Find the length of the chord. The question can be shown on the diagram as represented on the screen. So to find the length of this chord, when a straight line passes through the center of a circle and touches a chord, it divides the chord into 2 parts. So first of all, we are going to find the length CB of the chord using the Pythagoras theorem. From Pythagoras theorem, you have that the square of the hypotenuse, which is 17 squared, is equal to the sum of the square of the two other sides, which is a squared plus cb squared. And so when you evaluate these, you are going to have 289 minus 64, and then you have cb squared being equal to 225, and the square root of 225 is 15. When you multiply the length CB by 2, you have the full length of the chord, which is 30 centimeters. But sometimes you can also use another formula to find the length of a chord. The length of a chord can also be gotten using the formula 2 arrow sine theta or t all over 2, where arrow is the radius of the chord and t is the angle subtended by the chord at the center. So let's take an example involving how to find the length of a chord using this formula. You are told to find the length of the chord given on the diagram on the screen, where the radius of the circle is 15 centimeters and the chord subtends an angle of 30 degrees at the center of the circle. So using the formula D is equal to 2 arrow sine t all over 2, and you substitute the parameters given, you are going to have 2 brackets 15 sine 30 over 2. And when you evaluate 30 over 2, you have 15, and the sine of 15 is 0.2588. When you multiply this by 30, which is the angle subtended at the center, you have the length of the chord being equal to 7.76 centimeters. The next part of a circle we'll be taking is the arc. The length of an arc is the distance between any 2 points on the circumference or the perimeter of the circle. And so how do you find the length of an arc? Before then, you have two parts of an arc. You have the major part. The larger distance is called the major arc, while the minor or the shorter distance is called the minor arc. And so, but in most calculations, if the type of arc is not mentioned, it is assumed that it is the minor arc that is being referred to. How do you find the length of an arc? The length of an arc is equal to theta all over 360 times 2 pi r. And so this is the formula you use to find the length of an arc. Let's take a look at an example. An arc subtained 115 degrees at the center of a circle of radius 8 centimeter. What is the length of this arc? So to find the length of this arc, we are going to use the formula which I gave earlier. And so substituting into this formula, you are going to have that theta all over 360 times 2 pi will be equal to 115 degrees, which is the angle subtended by the arc at the center, all over 360 times 2 times 22 over 7 times 8, which is the radius of the circle. And so when you evaluate, you multiply all the numerator, you have 40,480. Evaluating, you have 16.06 as the answer. Next, we are to calculate the length of the minor arc in the diagram you see on the screen. However, you were given the angle subtended by the major arc. And so how do we calculate the length of this arc? To find the length of this arc, you first of all subtract the 315 degrees from the angle at a point which is 360 to get the angle subtended by the minor arc. Having done this, you substitute into the length of an arc formula, which is theta all over 360 times 2 pi r. And so you have 45 all over 360 times 2 times 22 over 7 times 8. And when you evaluate this expression, you are going to have 16.29 centimeter as the length of the arc. The fifth part of the circle I'll be teaching you is the sector of a circle. The sector of a circle is the part of a circle bounded by two radii along with the intersected arc. You can see that in the diagram on the screen. That area painted yellow is the sector of a circle. And so let's take some questions involving the sector of a circle. But the sector of a circle, you must remember, is also made up of two parts, which is the major sector and the minor sector. The larger area or part is called the major sector, while the smaller part of the sector is called the minor sector. The area of a sector can be calculated using the formula theta all over 360 times pi r squared. Let's take an example to explain how to use this formula. Calculate the area of a sector of a circle which obtain an angle of 60 degrees at the center of a circle of radius 6 centimeter, where pi is equal to 22 over 7. So using this formula, you are going to have 60 all over 360 times 22 over 7 times 6 squared, which will give you 18.85. To calculate the perimeter of a sector, you use the formula 2r plus theta all over 360 times 2 pi r, which is like adding the length of the two radii and adding it to the length of an arc. So let's take an example involving the perimeter of a sector. An arc subtends an angle of 90 degrees at the center of a circle whose radius is 7 centimeter. Calculate the perimeter of the sector taking pi as 22 over 7. The diagram is represented as seen on the screen. The perimeter of the sector will be equal to theta over 360 times 2 pi r plus 2r. Substituting the parameters given in the question, you are going to have 90 all over 360 times 2 times 22 over 7 times 7 plus 2 times 7, which will give you 25 centimeter. The next and the last part we'll be considering is the segment of a circle. The segment of a circle is the region of the circle that is bounded by the chord and an arc. The region is seen on the screen, which is colored green. You also have two parts of a segment. The larger part is called the major segment, while the smaller part is called the minor segment. But usually, if not specified, it is the minor segment that is being referred to. Let us take an example. Find the area of a segment cut off from a circle of radius 8 centimeter by a chord which subtends 100 degrees at the center of the circle, taking pi as 22/7. To find the area of a segment, you use the formula half AB sine C minus theta all over 360 times pi r squared. And so if you find the area of the circle AOB, which is half times 8, which is the radius of the circle, times 8 again, times the sine of 100, when you evaluate this, you are going to have 31.51 centimeters squared. You also find the area of the sector of the circle, which is theta all over 360 times pi r squared. When you evaluate this, you are going to have 24.31 centimeters squared as the answer. And let's take an example involving how to find the perimeter of a segment. A chord of length 11.3 centimeters subtending an angle of 90 degrees at the center of the circle. You are told to find the perimeter of the segment cut off by the chord. So you first of all find the length of the arc, which is theta all over 360 times 2 pi r. And when you substitute the parameters, you are going to have 12.57. You there subsequently add the length of the chord to this figure and you have 23.87 centimeter as the answer. That is it for today's class. Thanks for watching this video. I'll see you next time. Bye bye.